Well, today is your lucky day. We are starting the derivatives part of calculus, and this is going to be basically 50% of the calculus course. And this is some big stuff we're starting here. We're going to start with a very basic introduction, and that is, hey, what's a derivative? So an informal definition, one you won't find in a math book, is it's just an equation that can be used to find the slope of a curve at any point you care about. So let's think about this philosophically for a second. When you were in Algebra 1, your teacher asked you about slope a lot. So you'd get a line like that, and you'd do the old y minus y over x minus x, and you'd get a slope, in this case, -3/2. Well, the great thing about Algebra 1 is once you found the slope, that slope was valid at that spot, at that spot, at that spot, at that spot, and I could keep going on. So once you found the slope, problem solved. On a linear function, the slope never changes. But let's take a very, very friendly function, move into the world of calculus, and think about the slope of y equals x squared minus 6. I've marked 3 different spots, and all of those spots have a different slope. This one, if you wanted to visualize the slope, you kind of think of a tangent line like that. Tangent line is a line that just barely touches the graph in exactly one spot. At this spot, the tangent line would look like that, and up here the tangent line would look like this. Okay, probably not drawn all that great, but you get the point. So you could visually estimate the slopes, like right here. That tangent line is negative, or negatively sloped is a better way to say that. Slightly positively sloped and more positively sloped. But you can see that on a curvy graph, in this case a y equals x squared family graph, the slope is constantly changing. So your y minus y over x minus x is invalid for calculus. That's why we need a derivative. So now we're going to learn over the next, month, 2 months, a whole bunch of derivative rules. You don't even want to know how many derivative rules we're going to learn. So for right now, let's ignore the rule, and let me just show you this. This is the original function we're working with, and now we need a derivative. So the derivative, we're going to talk about symbolism in the next video, but this is the symbol for right now for derivative. We call that y prime. So this function has a derivative of y prime equals 2x. Don't worry about how we got it, and if you don't like that symbolism, don't worry, we're going to make it more understandable later. And if you wanted to write it in a slightly different form, you could say y prime of x equals 2x. So don't overthink this, this is the derivative. But now, since the derivative is an equation that will give you the slope at any point you care about, remember that's our definition, we can now start caring about different points. So for example, if I cared about this spot, it's approximately x equals 1, I take an x equals 1 and I plug it into my equation. In other words, y prime of 1 equals 2 times 1. That answer tells us that y prime of 1 equals 2, or this thing has a approximate slope of 2 at that spot. Your brain would tell you that this is a steeper slope. Congratulations, brain. Well, if this was at x equals 3, we would say, I want to know the slope at x equals 3, which is y prime of 3. So you take your 3, it's an x equals 3, plug it in, 2 times 3 is 6, you got it. And here, obviously a negative slope. Will the derivative confirm that? Of course it will. This is at x equals -2. So I take an x equals -2, I plug it into the derivative, that's what that symbolism is saying, and I get a -4 slope. And that's what our eyeballs tell us. Just like up here, our eyeballs told us that's pretty steep. So the derivative is simply a formula or an equation that will give you the slope of a curvy function at any point you care about. And remember, if you just draw a little tangent line, like you see here, or a little bit off the screen here, that tangent line is a visualization, a way to represent the slope with just a nice little visual. All right, so that's a brief introduction to what a derivative is. It gets much more complicated, but no matter how complicated it gets, we're always going to boil down to this one statement. The derivative is an equation that'll give you the slope of that curve at any point you care about. Off to better stuff in the future videos.